the first step to setting up compliance scanning on a RHEL client is to make sure the SCAP security guide and the OpenSCAP scanning tooling are installed on the client, which we'll do now with DNF. That completes the first step. After the tooling is installed, you can check to see that the content, the data stream, is available in the user share XML SCAP SSG content directory. And we can explore what information and specifically what compliance profiles are part of this data by using the OSCAP info command. And this shows us all the related profiles that we have available on the system to choose from in our compliance scanning and our compliance enforcement. Now, if we've never used this tooling before in the past, something that can be really helpful is to view the HTML output guide of these OpenSCAP profiles. So one of the ways we can do that is by generating a guide with the OSCAP command that'll output this in an HTML format for easy viewing. So this first command that I'm running here generates the overall guide, absent of a particular profile. And then you can also output an HTML overview of specific profiles. And in this command example here, I'm going to generate that for the CIS profile, which we'll use as our example today. And then if we look at the directories, we have these HTML files available for us for easy viewing of the contents within each of these profiles and guides for the OpenSCAP content. So opening up the first HTML guide, which is a general guide of the overall OpenSCAP content, we get to see a brief overview of what the content entails. And more interesting is in the table of contents, we get a broken down view of all the different settings, areas of the system that the OpenSCAP content is designed to address. So we see some examples here of file permissions and masks, specific profile guides for services, DNS, DHCP, networking, kernel configuration, etc. Similarly, for the CIS profile guide, I'm viewing the HTML version here. We get a similar synopsis of the content included in the CIS profile, as well as a more scoped set of table of contents to address things specific in the CIS profile that content is designed around. Some of it, you'll see some similarities from the overall generalized OpenSCAP content, but there's some expansion here into different areas, more specific as we dive down into the CIS content itself. And you'll see this is a good area where you can start to understand what exactly is included as far as the rule sets and the checking that the CIS profile or other profiles will do on the system. These guides are structured in enumeration of all the rules that it's going to check and the criteria contained within each rule that it's going to use as its scoring in comparing the baseline of the system to the overall compliance framework here. And so, diving into these HTML guides gives you a very verbose view of the things that this profile is going to check, and also the remediation pieces that are assigned and available to it to correct it. What's also really helpful with this compliance framework content that's installed on the system, bundled in with that content are Kickstart guides specific to these profiles, as well as Ansible playbooks designed to bring a system into compliance with that particular profile or framework. So if you wanted to build a brand new system already compliant to a standard, you could leverage the Kickstart file content here to do that. Or if you've got a golden image that you already use and you want an Ansible playbook to bring that into a standard as well, that content is already built here for you to do that, saving you boatloads of time testing that and building that on your own. So now that we've went over some of the content that gets included with the OpenSCAP and SCAP Security Guide tooling on the system, let's take a look at how we can actually use this. So, the big areas of this command are going to be OpenSCAP eval and OpenSCAP generate, whether we're baselining a system, i.e. eval, or if we're going to generate content or a fix outside of a report that an eval has already developed for us. So I've got here an OpenSCAP eval command that's referencing the default CIS profile for RHEL 9, and I've told the command to store the results of the compliance scan in the CIS results.xml file, and to also include an HTML formatted report that we can use to view the compliance results of that scan as well. So we'll run this command and it will go through all of the rules that we saw in that HTML guide and give the system either a pass or a fail or a not applicable rating to all of the different rules that exist in that profile or that compliance framework. And so I'll give it a few minutes to run through this, but this is essentially what the OpenSCAP tooling is going to be doing for you as it's baselining the system. And it's finished. So now that the scan is finished, I've opened the HTML report of the evaluation results. And so as we take a look at the HTML report here, we can see some of the evaluation characteristics of the scan that we ran and the resulting compliance and ultimate scoring of how our system did relative to the CIS framework. And so we can see here, I've got 124 rules that passed, 152 failed. The severity of the rules is broken down, and I've got an ultimate score of 72 and change out of a maximum 100. So I've got quite a bit of work left to do to make this system 100% compliant. And the rule overview is broken down into pass, fail, and a scoring of the severity of all the different rules that are here. So I can dive deeper into all of the areas where my system failed a compliance and all the areas where it was passable. And so this is what we can use to understand all the changes that we might need to do to a system as part of evaluating it for compliance and deciding whether or not it might make sense to remediate. Now, what's really powerful about this OpenSCAP compliance framework and tooling is that now that we've generated an eval and we've got a baseline report, both in XML and HTML format of our results, we can use the OpenSCAP tooling to generate a fix to bring that system into compliance. And so this is the other half of the OSCAP generate tooling. The first command we used was OSCAP eval. Here we're using OSCAP generate, and we're telling it the fix type that I want is Ansible. So our output is going to be an Ansible YAML formatted playbook specific to this system and the rules that didn't pass. And so what this command is going to do is it's going to generate a playbook specifically to this system to address all of the rules that had failed, and it's going to create several tasks in that playbook that are going to correct that result. So as that command's now done, if we open up the playbook that it generated, you can start to see the level of detail that it goes into for all of the different rule sets. There's an associated Ansible task and whether or not it applies to this system. And as we go through this playbook, you can see all of the content here that's already built for you. That would take, an administrator quite a bit of time to build this on their own. So it's wonderful that this content is here as part of this tooling, and we're able to generate playbooks specific to baseline evaluations to get very specific about the things we want to fix and address on our system. Now, what if we wanted to customize some of the content that's included in the CIS profile? So while, industry works towards setting what that CIS profile contains, maybe we don't want to enforce everything that's in it, or we want to add some things that may not be there. One of our options is with the SCAP workbench tooling. This is available in RHEL as well, and it allows us to customize or choose the rules that we want to include as part of that framework. And so as I've got this OpenSCAP workbench tool open, it gives me a list of content that I want to select. So I'll select the content here for RHEL 9. And here in the profiles, it gives me a listing of all the different profiles, just like the OSCAP info command did. And underneath there are all the different rules that make up that profile. Now from here, I can go in and customize the rules that I want and build what we call a tailoring file that keeps track of the rules that I want to add or subtract to this profile in order to customize it to exactly what I need. So beforehand, I've gone and customized a profile, and I'll show that to you here. So I've got the CIS level 2 profile, and I've made a tailoring file that only includes one rule, just for simplicity's sake. And so what I've done is I've taken that generalized CIS profile and I've customized it with the tailoring file to only include the rules that I care about. And this is what I can use as a repeatable way to customize this framework without having to edit the framework itself. So the power of the tailoring file is to be selective about the rules you want to enforce on the system without having to maintain the overall CIS framework yourself. Essentially, your maintenance work here is caring about your tailoring file and the rules that you want to enforce instead of having to build all of the CIS content on your own. You're just going to maintain a customization of what that content looks like for what you most care about in enforcing on your systems. So two of the outputs that you'll get from creating a tailoring file is both the tailoring file itself as well as the customized data stream content that the tailoring file relates to. And so where this is helpful is now we can use this in another eval command that scopes our scan specific to the new data stream content that you've modified, and the tailoring file, which includes just the rules that we define that we care about in that tailoring file that I showed you previously. So as we run this eval example, you'll notice that the only rule here that's going to be evaluated on the system is the disable SSH root login rule that I created in that very simplistic tailoring file. And so again, this is another way that the OpenSCAP content can help us define exactly what we want to enforce as our compliance policy and profiles on a RHEL client. So now that we've created that tailoring file that customizes the CIS profile content that we care about, what we can do is we can go back to the generate side of the OpenSCAP command and generate an Ansible playbook specifically to correct the rules that had failed from the previous eval scan. And so what this really allows us to do is get, again, very prescriptive in the rules and the enforcement that we want to apply to the system. So as that playbook's now generated, I can take a look at this tailored policy, the Ansible playbook, we can see that the content in here is just specific to the disable SSH root login rule and not all of the CIS rules from the first eval and playbook generation that we did. And so as we go through this content here, you'll see it's very scoped compared to the rule set that we had in there before. And so what this allows us to do now, or what we've essentially done, is we've baselined a system against a tailoring file that contains a customized profile of what we want to use as our compliance profile for this system. And then we've now generated an Ansible playbook specific to remediate just those rules that we cared about that may have failed in that eval. So to recap what we've went over here, we've taken a look at some of the OpenSCAP and SCAP security guide content that's included with RHEL. We've went through a couple examples of the OpenSCAP eval and OpenSCAP generate commands to show you how to baseline a system against a particular compliance profile, but also to generate an Ansible playbook that can remediate the concerns found in those initial baselines. And so now, while we've generated both an initial baseline evaluation and an Ansible playbook that can fix it, what we can also do with the eval command is pass a -- remediate switch to it to go out and fix the system and bring it into compliance according to the rule set that it failed. So if we take our old eval command and we append a -- remediate to it, as part of the eval scan, it's going to go through on the existing rule set according to the tailoring file that we created. And it's also going to do the remediation of the items that were identified that needed to be fixed. And so that's an easy way, in addition to the Ansible playbook, that we can use the OpenSCAP tooling to bring a system back into compliance. And so while I've shown you a couple of options to both do evals and generate fixes, both in an Ansible playbook as well as the -- remediate flag, something else we can do is we can let Satellite know about the playbook that we've generated. And so instead of going one by one on each RHEL system and running this playbook, we can have Satellite enforce that for us, which we'll show you in the next demo.